Imagine being widely considered the most prepared nation on Earth for a natural disaster, only to watch practically all of your defenses completely fail in just a single hour. Well, that's exactly what happened on March 11, 2011, when a towering black wall of water raced toward the Japanese coast. Within minutes, entire communities were just erased. But from that unimaginable devastation came a fierce determination to never let history repeat itself. Today, in this explainer, we're diving into how Japan responded with one of the most audacious coastal defense megaprojects in human history. We're going to explore the monumental scale, the cutting-edge Japan engineering, and the fierce debates behind building a truly unstoppable wall. So let's start with that terrifying statistic: 90%. That is the staggering failure rate of Japan's older seawalls within a single hour of the magnitude 9.0 earthquake. The infrastructural collapse was practically total. Prior to 2011, you have to remember, coastal towns had walls, they had warning systems, they had well-drilled evacuation routes. People really trusted the concrete. But nature simply scaled up in a way no one had properly modeled, shattering that sense of security in an absolute instant.
Now, the failure wasn't just a matter of the water being too high. Yes, the 2011 tsunami waves surged up to 15 meters, completely overtopping the old 8-meter walls. But the water didn't just crash over the front. The real destruction actually happened from behind. When millions of tons of seawater pour over a wall like that, it violently erodes the earth holding the structures in place. It literally washed away the soil, destroying the foundations from the back, causing these massive concrete fortifications to simply tip over and crumble right into the sea.
So this leaves us with a pretty massive engineering question, right? How do you build a wall capable of stopping an entire ocean? How do you create something that won't just stand up to an initial impact, but will actually survive being fully submerged and violently pulled at by receding waters? To do that, you have to rethink coastal defense from the bedrock up.
And the answer is an unprecedented feat of engineering. We are looking at a staggering $12.7 billion megaproject, featuring seawalls up to 15.5 meters tall. That's taller than a 4-story building. And it doesn't just protect 1 or 2 vulnerable bays either. This continuous fortified barrier stretches for roughly 400 kilometers. To put that massive scale into perspective, that is roughly the distance from New York to Boston and back twice.
This sprawling tsunami seawall spans the Tohoku coastline, cutting right across the Iwate, Miyagi, and Fukushima prefectures. It's an area that lost practically everything in 2011, but rebuilding here wasn't just about pouring more concrete. It demanded completely new construction techniques to protect hundreds of highly vulnerable communities. The logistics alone are just mind-boggling. We're talking intense coordination across dozens of municipalities and hundreds of local contractors, all racing against the clock before the next major seismic event hits.
Okay, so where do you even start building something like this? Well, the crucial first step was tackling the seabed itself. Engineers didn't just have one terrain to conquer. They had 3 entirely different seabed challenges. They had to build on soft, shifting ocean clay that couldn't even support a bulldozer, dense, compacted sand, and hard, jagged bedrock. Each zone required completely different foundational designs, executed simultaneously by 440 separate contracting teams. It's like a giant puzzle, because if even one team's section settled unevenly, a gap would open in the wall, rendering the whole shebang totally useless.
To pull this off, the complex underwater construction involved some truly innovative steps. First, they had to sink massive pneumatic caissons. Think of them as giant pressurized underwater construction chambers down as far as 25 meters deep into the active surf zone. Then, they placed geotextile membranes, which are essentially heavy-duty fabrics that let water pass through but stop fine soil particles from washing away. Finally, they compacted clay cores inside the walls to an exact 98% density. Why 98%? Because at that exact density, the clay forms an impermeable barrier to prevent internal erosion. If an inspector found it was compacted even a fraction less, the entire section literally had to be dug out and rebuilt, no exceptions.
Now, further out in Kamaishi Bay, they pushed the boundaries of marine construction even further. They actually set a Guinness World Record by sinking colossal caissons, each weighing an unbelievable 60,000 tons, into water 63 meters deep. Their goal? To rebuild the world's deepest breakwater. And this is vital, because a breakwater acts as the absolute first line of defense. It sits out in the open bay to shatter a wave's energy before it ever has a chance to reach the shoreline walls. Here is something really fascinating. We always picture a tsunami as a devastating incoming wave, right? But surprisingly, some of the most robust engineering in this project is designed for when the water leaves. The deep foundations and the thousands of 32-ton interlocking concrete tetrapods
lining the coast are actually designed to fight the vacuum pull of the retreating wave. This deadly force is known as backwash scour. That backwash acts like a massive vacuum, pulling the seabed and foundations straight out to sea. These new interlocking structures absorb that massive energy and hold the ground together when the water violently reverses direction. But seawalls alone can't protect a coast dotted with river mouths, which are basically nature's highways straight inland. The solution for this was a brilliant system of 443 automated floodgates, engineered to trigger seismically. The moment an earthquake is detected, the gates begin closing immediately, achieving a complete watertight seal in under 70 seconds entirely without human intervention. This automation is absolutely vital, because back in 2011, many firefighters tragically lost their lives trying to manually crank close the old sea gates as the water arrived.
To maintain this life-saving seal under the crushing pressure of a tsunami, engineers had to be obsessively precise. They ground the steel closures of these massive floodgates down to a microscopic 2mm tolerance. To put that in perspective, under the massive hydrostatic pressure of a tsunami wave, a tiny 2mm gap can quickly warp into a 20mm hole, blasting water through at high speed and undermining the entire structure. Perfecting that 2mm seal is quite literally the difference between a dry town and a completely flooded one.
And this entire system faced the ultimate unscripted stress test during a real magnitude 7.4 earthquake in March 2022. It was exactly the scenario they had designed for. The seismic sensors tripped, and across the Tohoku coast, all 443 gates sealed flawlessly. Furthermore, inspections after the quake showed 0 cracked panels, 0 shifted tetrapods. It was just an extraordinary validation of the strict tolerances and grueling construction standards they'd endured for over a decade.
However, this monumental achievement has sparked a fierce debate over the very future of coastal defense. It's known as the debate between gray defense and green defense. Should we rely entirely on impenetrable gray concrete walls to hold back the sea, or should we lean into green, nature-based defenses, like the initiative to plant 9 million deep-rooted disaster prevention trees along the shoreline to naturally buffer wave energy?
Impartially speaking, the data is undeniable. Past tsunamis clearly prove that seawalls over 5 meters drastically reduce fatalities and building damage. The concrete absolutely works. But critics correctly point out the severe ecological damage these massive walls cause. They cut off natural sediment flows and tidal habitats. Plus, for the local residents, living behind a 15-meter windowless concrete barrier creates a prison-like aesthetic, entirely severing their historical and visual connection to the ocean their communities were built upon in the first place.
So as we wrap up this explainer, in an era of warming, rising oceans, and increasingly extreme weather, we are left with a profound question that extends far beyond Japan. What is the optimal compromise between protecting human life with impenetrable gray fortresses and preserving our natural, green connection to the sea? Japan has built its Great Tsunami Seawall, offering us an incredible blueprint for survival. But the debate on how we choose to live alongside the raw power of nature, well, that's really just beginning.